Hi there, and welcome to this lesson. In this lesson, we'll be learning sine and cosine rules, okay? And under sine and cosine rules, we'll be learning about the sine rule. So we're going to start off with the sine rule. And basically, this is trigonometry, so sine and cosine trigonometry. There's something very interesting about the sine and cosine rule, and we're going to find out shortly, okay? But as the lesson progresses, anything you don't understand, be sure to contact your tutor who would be more than happy to help. And yeah, let's jump right into the lesson. So, the sine rule. Now, what exactly is this about? Now, up until now, we've been using trigonometry to solve right angle triangles. Okay, we have explored the sine and cosine and tangents of angles greater than 90 degrees, but then up until now, we've been using trigonometry to solve right angle triangles. But I'm going to introduce you to something new now, okay? And basically, we're going to be using trigonometry to solve other triangles, okay? Not just right angle triangle, but other triangles as well. And that is where we apply the sine and cosine rule. There are rules that are built on trigonometry, okay? But then we actually use them to solve trigonometry, or usually associated with right angle triangles, but we actually use them to solve other triangles, okay, not just right angle triangles. And yeah, consider the triangle below. So I have this triangle, clearly not a right angle triangle, okay, so it's just your regular triangle. And I'm going to label the three angles in this triangle A, B, and C. Okay, so we have three angles labeled A, B, and C, and I need to pay very close attention at this point, okay, because there is a very vital relationship that I'm going to establish at this point. So look, we have A, B, and C, okay, and if you look at the angle A, the side opposite A, okay, so the side facing A, I'm going to label with a small a. So the angle is capital A. The side, if you just look across from A, the side that's facing A, we're going to call small letter a. Okay, I'm going to do the same thing for B. Look at B and look at the side opposite B. Okay, the side, if you just draw from B, you look at the side opposite B, I'm going to label that small b. Okay, and then finally you have C, the angle C at the top there, and you can look at the side facing C and you have small c. So we have three angles A, B, and C, capital A, B, and C, and we have three sides, corresponding sides, okay, facing each of these angles labeled small a, B, and C. Now, there is a very important, very simple relationship here between the angles and their sides. And what it is that the sine rule is an established relationship between two sets of corresponding sides and angle. And what it is for every side and angle in this triangle, the ratio of the sine of the angle and the length of the corresponding side is always fixed. Okay, what does that mean? Basically, sine A over A equals sine B over B equals sine C over C. So if you have for example, you have sine A over A equals sine C over C, or you have sine B over B equals sine C over C, sine A over A equals sine B over B. But just know that for every angle, the ratio of the angle, the sine of the angle, and the length of the corresponding side is always fixed, and it's equal for all three angles, all three sets of angles and sides. So if you're ever given, let's say you have the angle A and you have the side A and you have the angle B and you're looking to find the side B, the side B, the length of the side B, that's small b, you would apply this formula, okay? And basically you just work your cross multiplication, dividing both sides, and you should end up with your answer. But let's do an example. Basically, that's all you need to know, okay? So you have three sides in a triangle, your regular triangle, not a right angle triangle, okay? And then you have the angle and the side facing that angle, the angle and the side facing for all three angles, okay? And we have a fixed ratio for each set of corresponding sides and angles. So sine A over A equals sine B over B equals sine C over C. And now let's do one example. So example one, okay? And we have using the sine rule, find the value of the letter side and the triangle below. Okay, so we have a triangle here, and we have two sets of sides and angles. So if you see, we have 60 degrees, and 60 degrees goes with M, okay? And we have 80 degrees, and 80 degrees goes with 11.7. All right, and now we're just going to go ahead and solve this triangle. Okay, we're going to go ahead and solve this triangle, and we're going to apply the sine rule. Now, so you never mistake it with the cosine rule. We'll learn about the cosine rule later, but something you need to know about the sine rule, like I said, it's an established relationship between two sets of corresponding sides and angles. So if you have if you're looking at two angles and their corresponding sides, basically which either any one of them missing, you apply the sine rule. The cosine rule, on the other hand, usually has let's say usually has one angle and works with three sides, but we'll learn about that all of that later. But right now, if you ever have two angles with their corresponding sides, okay, basically those are all of the parameters in question, and you're looking to work out any one of them, you apply the sine rule. For example, in this case, we have two angles and their corresponding sides, and we're looking to find one of those corresponding sides. So we apply the sine rule. So our sine rule says that sine 60 over m, okay, 60 goes with m, so sine 60 over m equals sine 80 over 11.7, okay, because 80 goes with 11.7, the corresponding side, the opposite side to 80 is 11.7 centimeters. So sine 60, sine a over a equals sine b over b, so sine 60 over m equals sine 80 over 11.7. And then we just go ahead and cross multiply. So we have 11.7 sine 60 equals m sine 80. And then we divide both sides by sine 80 to have m. Okay, and then we're left with m equals 11.7 sine 60 divided by sine 80. And when you work that out with your calculator, you should end up with m as that, basically. So yeah, that's it. Very simple. So that's pretty much all you need to know at this point, okay, regarding the sine rule. Just go ahead and do more examples. Like I said, if you have two sets of corresponding sides and angles, you apply the sine rule. Now, another example. Example 2. And example 2, we have using the sine rule, find the value of the lettered angle in the triangle below. Okay, so here we have another two sets of corresponding sides and angles, and we have theta going with 6.1 centimeters and 102 degrees going with 13.9 centimeters. So we have two sets of corresponding sides and angles, and we're looking to find one of them. Okay, so we apply the sine rule, and we just go ahead and solve that, and we say sine theta goes with 6.1, so sine theta over 6.1 equals sine 122 over 13.9. Okay, and then you cross multiply, you have 13.9 sine theta equals 6.1 sine 122, and you divide both sides by 13.9, you're left with sine theta. So you have that, and then you work that out with your calculator, you're left with 0.3721. Okay, and then when you find to be sine theta equals 0.3721, to find theta, you have sine inverse of 0.3721, and you're left with theta as 21.85 degrees. Simple, straightforward. Let's move on. Okay, so one final example, and something very interesting about the sine rule we're going to find out here. Okay, so we have this angle theta, and we're looking to find this angle theta. It goes with 10 centimeters, and we also have 28 degrees going with 7 centimeters. Okay, and then we're looking to find theta, so we apply the sine rule. So theta goes with 10, 28 goes with 7, and we have that sine theta over 10 is sine 28 over 7. Okay, and then we cross multiply, we have 7 sine theta equals 10 sine 28. And then we divide both sides by 7, so we have just sine theta on the left, and sine theta equals 10 sine 28 divided by 7. And when you work that with your calculator, you have sine theta as 0.2235 Okay, and then if you find the sine inverse of 0.2235, so to get theta, you find the sine inverse of 0.2235 on your calculator, you have 12.92. Now, something very interesting. Okay, so we have theta equals 12.92. But if you look back at the diagram we have there, that angle is clearly not 12.92. That angle is bigger than 90 degrees. Okay, and it's something you need to watch out for when you're using the sine rule. The reason for this, theta is actually 180 minus 12.92. Theta is actually 167.08. So if you're ever solving with the sine when you get an angle, and you look at your angle is big, like what we have here, and the result you get is small, so you have 12.92. Clearly that angle is not 12.92. You subtract that answer from 180 and you get the correct answer. But you need to be very, very careful about it. It only applies, you basically just need to use your head, okay? You just need to think about it. Look at what you have. The angle you have there is clearly bigger than 90 degrees, so it couldn't possibly be 12.92 degrees. And the reason for this is that the sine of an angle equals the sine of 180 minus that angle. So the sine of 30 degrees is the same as 180 minus 30, 150 degrees. The sine of 60 degrees is the same as the sine of 120 degrees. It's something very, very interesting when you're working with the sine rule, okay? And but the thing is, anytime you find the sine inverse of a a number, your calculator would always give you the smaller number. Okay, it would not give you the corresponding 180. Usually it should tell you, for example, if you find the sine inverse of 0.5, your calculator should tell you 30 or 150 degrees. Okay, but your calculator is only programmed to think between 0 and 90 degrees. So if you ever face with something like this where the answer is clearly 167.08, but your calculator will tell you 12.92, because your calculator cannot think to give you that answer, the 167.08. But if you look clearly at the question, clearly that angle is bigger than 90 degrees, so it couldn't possibly be 12.92. So you go 180 minus 12.92 and you get the correct answer, 167.08. And yes, that will bring us to the end of this very simple, very interesting. Really, really, you just need to get the core principles, okay, when you work in the sine rule. Know that the angles and the side, know how they correspond. So the angle, each angle goes with the side opposite, directly opposite it. And then basically for each of the angle, the sine of each of the angle and then divided by their corresponding side equals the sine of the other one divided by its corresponding side equals the side of the sine of the other one divided by its corresponding side, and pretty much that. Okay, yeah, you can go ahead now and attempt questions on the worksheet. Bye for now.